So today we're looking at proportional and non-proportional relationships in graphs. And the first problem says you've been hired by your neighbors to babysit their children on Friday night. You're paid $8 per hour. Complete the table by relating your pay to the number of hours worked. So I'd like for you to pause the video and fill out the table, and then when you come back, we'll work it out together. All right, so first of all, we know that complete relating pay to the number of hours. So we know our ratio is going to be pay to hours. And we could also do pay colon hours. And so we are going to then have pay as the numerator and hours as the denominator. So when we look at our okay, so we got, first of all, let's find out that if we're gonna work 1 hour, we'll fill out the table, it's gonna be $8. 2 hours, we multiply 2 times 8, we get $16. 3 times 8, we get $24. 4 times 8, we get $32. 4.5 times 8, if I do 8 times 4, it's 32, and then 8 times a half is 4, so 32 plus 4 is $36. 5 hours is $40. 6 hours is $48. And if I go 6.5 hours, that's 48. Half of 8 is 4, so that'll be $52 if I add those together using the distributive property. So it says, based on the table above, is the pay proportional to the hours worked? Well, we definitely know that because, first of all, we could go through and we could divide each one of these, and we could say pay over hours. So if we do pay over hours, 8 over 1, 8 divided by 1, it's going to be $8 per hour. If we do 16 divided by 2, that's going to be $8 per hour. 24 divided by 3, $8 per hour. 32 divided by 4, $8 per hour. 36 divided by 4.5 or 4.5 is going to be 8. 40 divided by 5 is going to be 8. 48 divided by 6 is going to be 8. And 52 divided by 6.5 is going to be 8. So we have 8 for each one of these. So we know that since our unit rate is the same, then we know that the proportion pay to hours has to be the same. We can also say that if we're going to multiply each one of these times 8, okay, then each one of them is being multiplied by 8, so it's definitely in the same proportion. They are proportional to each other. Another way we can look at that is we can say y equals k times x, where k is my unit rate. And if we do that, then when we're going pay to hours, pay depends on the number of hours, so that's y, our dependent variable. And the hours worked would be x, that's our independent variable. So we're really starting to stress making sure that you know which one would be x and which one would be y. Y is always dependent, so pay depends on how many hours you work, otherwise you won't get paid. If you had 0, 0, and that was one of our points, or we said we worked 0 hours, then we would get 0 pay. So that would work out if I had 0, 0 in here. That would be 0 is equal to k times 0, or 8 times 0. And yep, that's 0. So if you don't work anything, you're not going to get paid. Now, could we determine how much pay you would get for a week working 20 hours? Well, sure. Okay, if you've got 20 hours, that's going to be x. You're going to multiply that times your unit rate, which is 8, and that's going to give you y. So here, k times x, that's going to equal y, and that's our pay, so that'll be $160. Okay, so in the next tables, we are going to determine if y is proportional to x. Now again, if y is proportional to x, that means y is in the numerator, x is in the denominator. Y is our dependent variable, X is our independent variable. And let's see if that's the case. Yeah, how much snow falls depends on how many hours it snows. And so if we want the rate of snow, that will tell us if this is proportional or not. So if I take 10 divided by 2, I get 5 inches per hour. If I do 12 divided by 6, I don't get 5, I get 2 inches per hour. So as soon as you find two unit rates that are not the same, then you know that you all can't be proportional. To show that they're proportional, you have to check each one of them to see if you get the same proportion or the same unit rate. But here we've got two that are different, so that's going to be a no. Okay, no, and that's because, think about what that would be because of. And that would be because all the ratios don't have the same unit rate, or there's not one number such that each number, x times that multiplied, x multiplied by the number gives the corresponding measure of y. So there is not a consistent unit rate, or we can't take each one of these. We can't take 2 times, here we're taking 2 times 5 equals 10, and the next time we're taking 6 times 2 equals 10. So these are not the same unit rate. Oh, I'm sorry, it's 12, not 10. So since there's not a consistent unit rate or a consistent K that I can multiply times the snowfall, or times the time to get the snowfall in inches, then it is not proportional. So if we look at the next table, okay, so again we're doing y to x. So if we do, can we find a number that we can multiply times 6 to get 2? We could multiply by a third. We can take 9 times a third to get 3. We can take 24 times a third to get 8. We can take 3 times a third to get 1. So that should be, well, let's check with our unit rate. So we're going to take cos 2 divided by 6. If I reduce that, that's 1/3. If I take cos 3 divided by 9, that reduces also to 1/3 because I can divide a 3 out of both of those. If I take 8 divided by 24, divide out the 8 over 8, I get 1/3. And if I take 3 divided by 1, no, I'm sorry, 1 divided by 3, that's the same thing as 1/3. So my unit rate is 1/3. So that means that I can take my x times 1/3 and I should get y. Well, let's see. 6 times a third, yep, 6 over 1. I can multiply straight across and get 6 over 3, and that's going to be 2. Or I could divide out the 3 here and get 2 times 1 over 1 times 1. If I do 9 times a third, yep, a third of 9 is like 9 divided by 3, which is 3. And so on down the line. We've already really talked about that one, so that one checks. Okay, the third one, table below shows the relationship between the amount of candy in pounds bought and the total cost y. So that's going to be cost per pound, or again that's going to be y over x, same thing. So that's my unit rate. So if I do 10 divided by 5, I get 2. 8 divided by 4, I get 2. 12 divided by 6, I get 2. 16 divided by 8, I get 2. 20 divided by 10, I get 2. Okay, so to justify our answer, again, we can say yes, it's proportional because it has a consistent unit rate. Or I can say that anytime I take my x and take it times the unit rate, k, I get y. So let's see. 5 times the unit rate 2 is 10. 4 times the unit rate 2 is 8. 6 times the unit rate 2 is 12. 8 times the unit rate 2 is 16. And 10 times the unit rate 2 is 20. All right, so now we're going to look at the back side of your notes. And we've got one more example. It says, Randy is planning to drive from New Jersey to Florida And Randy recorded the distance traveled and the total number of gallons used every time he stopped for gas. Assume miles driven is proportional to gallons consumed in order to complete the table. So we're saying that miles is proportional to gallons, so that's miles to gallons. So we're assuming that is proportional. So if I do miles divided by gallons, I should get the unit rate. And that's like miles per gallon. So if I take 54 and divide it by 2, I get 27. And if we check over here, 216 divided by 8 is also 27. So in that case, if I multiply, and it says fill in the rest of the table, so that means 4 times the unit rate 27. So this is my x, this is my y. So the unit rate times x should give me the number of gallons, or miles per gallon. I'm sorry. The gallons times the miles per gallon that I should get should tell me how many miles I've driven. So that would be 108 miles. Now here I've got 189 miles driven. So if I divide that by the unit rate, that should tell me that that is 7. I've used 7 gallons of gas. If I drove 216 miles, we already know that that is 8 gallons consumed. If we have 10 gallons of gas consumed and we multiply that by 27, then that will be 270 miles driven. And if I have 12 gallons and I usually get 27 miles to the gallon, then 27 times 12 means I should be able to go 324 miles. Okay, since the quantities are proportional, then every ratio comparing the miles to gallons consumed must be equal. Using the given values for each quantity, the ratio is 54 divided by 2. Well, there it is right there. Okay, let's see. So here, when we're figuring out the number of miles driven, we're using our y equals kx. Here's my k, here's my x, and here's my y. In this situation, we're taking our y, we're dividing it by k, the unit rate, and that gives us our x, which is 7. And the same thing here. That's going to be y equals the unit rate, 27 times x, and so on and so forth. And then our lesson summary, you can read that to yourself. And tomorrow you'll do the exit slip, and then you'll get your practice problems. Have a good evening.